Hello everyone. Hello. Good morning everyone. Today we will see some manufacturing process of glass fibers and carbon fiber materials. As you know, glass fiber and carbon fibers are the two main basic types of fiber materials. Fiber materials are classified based on different ways, but based on availability of fibers, fibers are classified into natural fibers or naturally what are available in scientific fibers. Scientific fibers are fibers which are made by human being or by human efforts. From those, today we will see from scientific fiber materials. From them we will see some manufacturing process of glass fibers and carbon fibers. The main difference between glass fibers and carbon fibers are their strengths. Their strengths. Carbon fiber materials are more stronger than glass fibers. Both have many applications in engineering applications for automobile body panel, aerospace, in marine engineering they are used those fibers more than other fibers due to their high mechanical properties and their efficiencies. So how they are manufactured? How they are manufactured? We will see how glass fiber materials are processed or manufactured in shortly. A glass fiber manufacturing process has effectively two variants. Glass fiber manufacturing process are classified into two main categories. Those categories are direct melting process and marble melting process. We will see one by one. Direct melting process in which a furnace is continuously discharged with raw materials or silicon dioxide. Many raw materials used for producing glass fibers are silicon dioxide, which are melted and refined as the glass reaches the forehead, foreheads above a set of platinum rhodium bushing from which the fibers are drawn. There were five main steps to manufacturing the continuous fibers. In glass fiber manufacturing process and direct melting process, it is classified into five five main steps. The first steps of direct melting process are batching process or collecting of raw materials from different areas by different mechanisms. In the initial stage or batching stage of glass manufacture, materials must be carefully weighted in exact quantities and thoroughly mixed. Mixed means batched. So when materials are batched from different areas, they are weighted. Q, the next step. The next, more than half of the mix is silicon sands because glass fibers are made from silicon dioxide. Silicon means has many in many amounts. Silicon sands are types of silicon dioxide. The basic building blocks of any glass. The basic buildings of any glass are was silicon sands. Then the second steps was melting process. Melting means after batching process, after many process was done, cleaning of the material, removing of unnecessary minerals. The second step is melting process. From the batching hose, the pneumatic conveyors for transporting from the batching to the melting process. We use the conveyors. Send the mixtures to a high temperatures of 1400 centigrade furnace for melting. for melting the silken sands. The furnace is typically divided into three sections with channels that aid glaciers, which means that furnace has three channel sections for melting, for separating ancillary materials, and so on. Uh, those sections are under the sections of these furnaces where first sections receive the batch, which means that the furnace have three sections. Those sections are the first sections receive the batch from the batching room where melting occurs. In the first sections of the furnace, melting was starting and uniformity is increased, including removal of bubbles. The temperature is too high at the sand and other ingredients dissolve into the molten glass. In here, melting process is started. The second sections was the molten glass, then flow into the refine, where its temperature is reduced to 1370 degrees Celsius. In the first sections, the silken sand was melted at 1400 degrees centigrade. So in the second sections, the temperature should be reduced to 1370 degrees Celsius. The third section is for hertz is to receive glass from the furnace, reduce its temperature to the desired level and discharge it to the forming sections at a uniform temperatures. In here, the temperature is reduced at a uniform level. The third step in glass manufacturing process is fiberizations. The first step is batching, melting process, and fiberization process. After the melting process is finished, we start fiberization process, which means forming of the fiber. Glass fiber formations or fiberization involves combinations of extrusion process, and attenuation. We will see one by one what's extrusions and attenuations. In extrusions, the molten glass passes out of the force earth, which means the third sections of the furnace through the bushing made of an erosion resistant platinum alloys very fine orifice. Automation is the process of mechanical drawing the extruded streams of molten glass into fibers. Element is called filaments for gaining filament with a diameter ranging from 4 p to 34, which means 1/10 the diameter of human hair. 1/10 the diameter of the human hairs. We can producing manufacturing at different levels of the diameters of the fibers, but we should be focused on the diameters of the orifice. The high-speed winder batch catch the molten streams, and because it revolves at a circumferential speed or much faster than the molten glass exists, the bushings. Tension is applied. Tightening process should be applied, drawing them into the thin filaments. This process is known as attenuation process. The fourth step is after fiberization process is coating step. After we make a fiber, we should be coat. Coating should be used for protecting or used for enhancing the mechanical properties of the formed fibers. Okay, in the final stage, chemical coating or size is applied. Size is typically added to at 0.5 to 2% by weight and may include lubricants, binders, or coupling agent should be applied in creating steps or on 4 steps. Lubricants help to protect the filaments from abrading and breaking as they are collected and wound into forming packages and later when they are processed by woven or other converters into fabric or other reinforcement forms, which means the formed fibers or formed glass fibers are used for as a reinforcement material in composite materials, reinforcement material. So, at fourth stage, creating process should be done. Next to fiberization process, the fifth stage is drying or packaging. After creating, after we are creating the form fiber, we should be dry or packing, which means the final stage of the manufacturing process. Finally, the drawn size filaments are collected together into a bundle, forming a glass strands composite of 51 to 1624 filaments. The strand is wound onto, which means strand means this wounded onto the drum. Drum means this section is known as drum into a forming package that reasonable spool of thread. The forming package still waits from water cooling and sizing. After the products are created, cooling process should be done. Cooling process should be done are then dried in a oven and afterward they are ready to be palletized and shipped or further processed into the chipped fibers, roving or yarns, forming yarn for roving and so on. This process are really how we are manufacturing glass fibers. The first stage is batching process, collecting of silicon dioxide or silicon sands from everywhere. Then we are waiting, transporting by the conveyors. Then you fed into the furnace, which means for melting. After batching process, melting process should be done. Then in here in a furnace at 1400 degrees centigrade, the silicon sands should be melted or converted into liquid. Then refining process at fourth stage. Refining means forming of fiber. Then for heated, this one is the sections of the furnace. Melting, refining, and for heated. In here, the temperature available in here is less than the temperature at melting point. In here, the available temperature is 1370 degrees centigrade. It is minimized by 30 degrees centigrade. Then, after melting process, fiberization process started like this one. Fiberization process is started like this one. Then, in here, after that, after fiberization process are done, the fourth step is known as creating process. In here, we should be created for protecting the produced material, then transporting or collecting of the material after this process. So, fully process of melting, process of direct melting, manufacturing process of glass fiber is look like this one. We will see the second one is marble melting process. Almost this process is similar with direct melting process, but their main great difference is only. One involves the preparations of marble. The marble should be prepared up to here, which means the second steps of direct melting process, which are remelted means again melting process should be done in fiberization stage, which means collecting silicon, weighting and mixing, then transport to the batching melting process start in here and three sections of the furnace, but this furnace have two sections in marble melting process. The third step is transfer to here. That step is known as marbleization process. Marble or remelting. After the fibers, the marble forming machine. This machine is used for making the marble. This is marble material. Then again it is transported to this section by the conveyor, melting in the marble bush. In here, melting process is again applied again. Then filament formations look like this one with sizing application means as we went we can adjust the size of the filament or the size of filaments. Then we are strand formation in here by transversing of windings of the prepared materials. These processes are securing and secondary processing of manufacturing process of glass fibers. So this full process is known as marble melting process. Marble melting process should be almost similar with direct melting, except it is remelted. The glass flows under hydrostatic pressure or weights of the glass melt column above the nozzles, and fine filaments of H15 micron average final diameters are drawn mechanically downwards at the speed of 1000 meters per unit or more than this one. The process should be done. The viscosity of the glass melt, hydrostatic pressures, the diameters and lengths of the nozzles and winding speeds are the most important parameters in which the, to determine the diameters of the drawn glass fibers. For determining the formed fiber diameters, we should be focused on those hydrostatic pressures, glass melted, or the viscosity of the melted glass, and the nozzles should be determined those such fibers. Fibers are immediately cooled by sprayed water at bushings. After the fibers are formed, after creating process, it should be coiled, coated with size assembled into strands and wound to produce cake. The size or finished is crucial to the handleability of fibers and their compatibilities with the matrix. The size is chosen to suit applications or further processing. The finish consists of under finishing process we should be address those process annotation promoters or coupling agent, protective polymeric size or film former, lubricants, and an optimal polymeric binder or emulsion or powder used for fiber mats. Those are the forms of glass fiber or availabilities of glass fibers after it is are formed. Maybe it is short or continuous glass fibers are used in different forms for various applications or composite products. In general, the size of the glass fibers are have the main effects on the strength of the prepared composites. Maybe the composite produced are available in different with fiber size. Maybe it's continuous fiber, discontinuous or chopped fiber, or in a form of powder also, reinforcement materials of the composite materials. But as the size of the fibers reduced in length, the strength of the composite material should be increased increased even if at nano powder. So this one availability forms of the glass fiber forms fiberglass mat. This one is fiberglass mat. This also available in a mat form, in a powder form. This one is chopped form. This one is in a mat form. This one is chopped roving. Unidirectional glass fiber means the orientations of the fibers are only on one side. This one is biaxial glass fiber, or the orientations of the fibers are criss-cross at 90 degrees. Maybe these orientations are 45 degrees, but when the fiber orientations was at 90 degree or at 45 degree or at 0 degree means unidirectional, the mechanical behaviors of the produced composite should be varied or changed based on the fiber orientations, which means that the fiber orientations have its main impact on the strength of the composite. Yarns, this one is available on a yarn form, means 5 single fibers. This one is the mat forms or woven fiber. This one is fiber glass roving. Graphite fiber manufacturing process. How we are manufacturing graphite also. It has its own process or steps. Percolate materials. Precursor materials which is rich in carbon is subjected to pyrolysis to extract its carbon. Pyrolysis means the process of removing or extracting carbon from the materials. Pyrolysis thermochemical decompositions of organic materials when it is subject to elevated temperatures but no oxygens. In here, when we are removing carbon from organic materials, this process is known as pyrolysis process. But we are not used oxygens without oxygens at elevated temperatures. This process should be done. Through such process, the precursor organic materials breaks down into gases, liquids, and solid residue which is rich in carbon. Precursor is a carbon-rich chemical compounds used as raw materials for pyrolysis process. Mainly, three materials are used as precursors. These are polycrylene or PAN, the most popular for these materials. Second one is pitch. It is the viscous substance produced by plants and also extracted from petroleum materials. It is made from plants and petroleum materials. Third one is rayon. It is regeneration cellulose fiber produced from naturally occurring polymers. Rayon made from polymers. Pitch made from petroleums and plants. Graphite manufacturing process. Good precursors material should have the following characteristics. First one is sufficient strength and handle properties so that it can hold together fibers during carbon fiber production process. Should not melt during production process. Should not be completely violet as it will dramatically reduce yields of carbon fiber. Carbon at most should self-align in graphite structure during pyrolysis process, during decomposition, or during removing carbon from materials. Carbon inexpensive process. Productions of graphite fibers from pan, maybe from pan, rayon. Pan precursor materials usually initially spun into fiber forms. This precursor process are then stretched through applications of tensile load. Stretching process done on here. During the stretching, they are also subjected to high temperature. The temperature should be applied on it. Then we are pulling under tensions for approximately 24 hours in an oxidation atmosphere. This process is called stabilization. These stabilization fibers are next subject to pyrolysis at we increase the temperature 200 to 3 1000 to 500 in Earth atmosphere. This process is called carbonization process. Carbonization is removing of carbon. During this process, most of non-carbon elements are driven out of pan fiber. So carbons was removed in here process. Next, these fibers are graphitized by heating them at high temperature. We should be increasing also temperature also. In Earth environment, this improves tensile modulus of the fiber as a graphite crystal developed in carbon. This one process is fully how we are manufacturing graphite from a pan materials. These are fully process of manufacturing graphite fiber from pan fiber. So we start in here stretching process, stretching or tension process is done in here. Stabilization process are done in here. Then we increase the temperature, carbonization process, removing carbon. Then graphitization process, forming of the graphite. In here also pooling process is done. Then surface treatment for enhancing the mechanical properties of the materials. Winding process is done. Conversions of pan fiber to graphite. How we are converting pan fiber into graphite fibers. This fully process shows that. Overviews of different types of graphite fibers. Pan fiber based on carbon fiber. Low cost and 90% of carbon fibers are made from pan fiber. 90% of carbon fibers should be made from pan fiber, pan type. Reasonable mechanical properties. Very popular in aircraft, missile, space applications. Type glass fiber, no, graphite fiber made from pans are used for those, or we are used in these areas highly. Pitch-based carbon fiber. This one is the second types of carbon fiber, glass fiber, graphite fiber. High stiffness, higher thermal conductivity. This makes them particularly useful in satellite structures. Rayon-based carbon fibers not used much in structural applications. Royal are not used in structural, or some of what is available, but not when we compare to the others. Low thermal conductivity, useful for insulation materials and heat shields, used in rocket missiles, the nozzles of the rockets, missile re-entry nose cones, heat insulations. Those are overviews of different types of graphite fibers. So, as summarizations, today we will see two main manufacturing process of fibers for glass fibers and graphite fibers, how they are made or how they are manufactured in detail. We discussed in today lessons. Thank you for watching our videos. If it is good for, if you are satisfied for this video, please share for your friends. Subscribe my channel. Thank you. Thank you.